All right, the next section is going to do the opposite of what we've just been doing. This time, we're going to be asked to find the z-score when we're given an area. So this is doing the exact opposite of what we have already been doing. So again, a couple of ways to do this. From the chart, you can use the chart. All right. So the chart says that we want a cumulative area of this. So cumulative is going to mean to the left, because remember, we're always going left. So this is going to be to the left, which is good. So on my chart, if I go back to my chart, I'm looking for the value 0.3632. So on my chart, 0.36. Well, this is 0.5. So I'll go to the first one. So 0.3632. 3632 is this value right here, which corresponds to negative 0.3, go up, 5. So from the chart, it's going to be negative 0.35. And that is your z-score. One more time. From the chart, find the area that you're asked for. Your area that you're asked for in this case is 0.3632. I'm going to go back. It's going to be the negative 3.3. And if I go up, it's going to be the 5. So negative 0.35. And that corresponds to your z-score. So let's do the second one. Find a z-score that has 10.75% to the right. This time we're going to the right. Since we're going to the right, we have to subtract from 1. So 1 minus 0.1075, because remember I have to change that from a percent to a decimal, and 10.75%, 2 places to the left, gives me 0.1075. 1 minus 0.1075 gives me 0.8925. So in my chart, 0.8925, 0.8925, 0.8925 is this value right here, which is 1.24. 1.24. 1.24. And again, that is the z-score. What is nice about this, though, is you can also, again, use your calculator. Because we are doing the opposite of what we've done before, we can't use the same function. We have to use a different function. And so the function we're going to use this time is going to be the inverse normal. Inverse normal. Inverse means opposite. So opposite of the normal would be the inverse normal. We're doing the opposite. This time we're going to type in the area that we're looking for. Again, mean of 0, standard deviation is 1. So the area, mean is 0, standard deviation is still 1. So I'll have inverse norm, 3, 6, 3, 2, comma, 0, comma, 1. So on my calculator, the inverse normal is also still a distribution. So second bars. Number 3 is the inverse norm. So number 3. All right, depending on how your calculator is, the area that we're looking for in this first case was 0.3632. 0 and 1 are automatically in there for you. Hit paste. Hit enter again. And my answer is 0.349918. So on the calculator here we get negative 0.349918. I think it was 18. Yep. So technically this does not round. It's close, but it does not round to the same value. If I rounded it, if you're looking at 4 decimal places, let me rephrase that. Remember, your chart doesn't go out to 4 decimal places. And it's okay if you're using MyMathLab, it's going to give you some differences in error allowances. So if you typed in negative 0.3499, you'd get it correct if you typed in negative 0.35. They give you some allowance in your decimal points, unless it specifically says type to 4 decimal places. So be sure that you're just looking for what it asks you to do. So the second one here, then, we would do inverse norm of, so we want this value, so the 0.8925, comma 0, comma 1. If you use your calculator on that one, so inverse norm .8925, hit enter, and it's 1.2399, 1.2399 for 4 decimal places, which to 2 decimal places does round to 1.20. So in this case, when you're rounding again, it's the same. If you're not rounding, you're not going to get the same answer. But it'll be close. Should be very, very close. All right. So how does this equate then to percentiles, which is what's going next? Well, this is very simple because a percentile goes directly to the area. So the 5th percentile says that my area is equal to the 5th percent, which again, if we change that to a decimal, is 0.05. So I can go straight to my calculator, do inverse norm, 0.5, comma 0, comma 1. Get an answer. So for P50, that would be an area equal to 50%, which is 0.5. So we would have inverse norm 0.5, comma 0, comma 1. And for the 90th percentile, again, that's looking at the area equal to 90% for 0.9. So we would do inverse norm 0.9, comma 0, comma 1. And again, for the sake of time, you can check and verify on your calculator, which you should. This value is negative 1.645. the 2 decimal places would be 0.165. This one is equal to 0, because remember the area at 50% exactly is half the graph. So 0 for the mean. And the last one is 1.282, which if you round it again is 1.28. So again, that's going to make it very simple to find it. All right, next then. So this time, we're going to, since we're doing the opposite, instead of finding x values, we're going to find, instead of finding the z value, the z-score, we're going to find the x value. So this is going to change from z to x. From x to z is this formula. Z equals x minus the mean divided by standard deviation. So the x then is mean plus standard deviation times the z-score. And that's a direct reflection of the algebra from here. So if I were to cross multiply, say 0 over 1, I would have z times the standard deviation equals 2x minus mu. I want to get x by itself, so I'd add mu to both sides. And x is indeed equal to mu plus z times standard deviation. So that's where the formula comes from. So direct change in the formula from z to x and x to z. They're inverses of each other. They're opposites. So, example, find the x value that corresponds to the z-score. So x is going to equal mu plus z times the standard deviation. Very simple formula. So number 1, x equals, says the mean is 9 pounds, standard deviation is 2 pounds. So mean is 9, standard deviation is 2. I guess we didn't read the problem. A veterinarian records the weights of cats treated at the clinic. The weights are normally distributed with a mean of 9 pounds, standard deviation of 2. Find the weights x that correspond to each z-score. So a z-score of x, z equals 1.96. We want to know in real life, because remember, x is real data. X is the real data. So how many cats have a z-score of 1.96, or what is the weight of those cats? Not how many, but what is the weight? Okay. So we would have x equals mean plus z times the standard deviation. So x is equal to, the mean is 9, the standard deviation, the z was 1.96 times 2. If you use your calculator, you can type it in just like you see it. So 9 plus 1.96. Yep. I forgot the plus. Okay. 9 plus 1.96 times 2 for the standard deviation. Hit enter. Come on. And I get 12.92. And again, this is real data, so that's pounds. So a cat that weighs 12.92 pounds would have a z-score of 1.96, which is very close to 2 standard deviations. So this cat would be 2 standard deviations from the mean. So the Z-score is very close to 2 standard deviations. So that means he's going to be a fat cat. All right, second one says Z equals negative. So this guy's going to be smaller than average. So negative means he's going to be smaller than average. So if the average is 9 pounds, he should be smaller. So X equals 9 plus the negative 0.44 times 2. Again, you put in your calculator. If you do it correctly using parentheses, then you would end up with 8.12 pounds, which is smaller, obviously, than the average of 9 pounds. Now, what happens if Z equals 0? Well, if Z equals 0, then this is going to be like the mean, because Z is 0. You're right there in the middle. So the mean is 9. So my answer should be 9. Now, of course, you can calculate it out. You would have X equals 9 plus 0 times 2. 0 times anything is 0. So that's just 9 pounds. So when Z is 0, this means the average, or mean. All right, some examples then. Scores for the California Peace Office Standards and Training Test are normally distributed, that's good, with a mean of 50, standard deviation of 10. So mean is 50, standard deviation is 10. An agency will only hire applicants with scores in the top 10%. What is the lowest score you can earn and still be eligible for that top 10%? Okay. So let's interpret now. Top 10% equates to the 90th percentile. 90th percentile. So if we were to think, okay, I need to find the X value, because again, I want the real score, the lowest score. I want that real score. So if I'm looking at my formula, X equals mean plus Z times standard deviation. Well, I know the mean, that's 50. I know the standard deviation, that's 10, but I don't know Z. So the first thing I have to do is find Z. So how do I find a Z score? Right? Well, the Z score is going to be to do the inverse norm, 0.9, 0, 1. And if I do that, I end up with 1.282. Because I want the top 10%, I know that I'm going to go to the right here. So this value is going to stay positive, which makes sense. So now I can do my X. X equals 50 plus 1.282 times 10. Multiply and add that together, and I end up with 62.8 being the lowest score accepted. Average was 50 on the test, They want people with a 68.2%. All right, next example. In a randomly selected sample of women aged 20 to 34, the mean cholesterol is 179. So the mean is 179. Standard deviation is 38.9. Assume the total cholesterols are normally distributed. Find the highest cholesterol level in women. Level a woman in this age group can have and still be in the bottom 1%. So bottom 1%. So bottom 1% is going to equate to the first percentile. So similar to the problem above, we're going to have to first find the Z. So I have to first find Z. And my Z is going to come from the inverse normal of 0.01, 0, 1, which is equal to negative 2.326, which again should make sense that it's negative because it's smaller bottom. So it's the bottom 1%, so it better be negative. We're looking at the very smallest number. And now, second step, we're going to find the X value, because I want to know the highest cholesterol level a woman can be and still be in the bottom 1%. So I want a real value this time. So X equals mean 179 plus the Z-score, which is negative 2.326 times 38.9. Again, use your calculator. And this is going to be approximately 88.52. This will probably round to 89 because cholesterol levels are usually not necessarily a decimal. But again, depending on what your calculator or what your homework asks you for, we'll have to round appropriately. And that wraps up section 3, opposite of what we did before.